Hi everyone, it's Lily. My chemical was benzoate which is also known as BAP. It's a polycarbon aromatic compound and it's shown to have adverse health effects on pretty much every organ. So the liver, kidney, cardiovascular system, respiratory system, and reproductive organs in particular. Some common ways that benzoate can get into humans is through ingestion and inhalation. It can be there can be dermal exposure, however, there needs to be long-term and really high concentrations of it. So playing in soil or working in soil and not washing your hands, that's when you get exposed. However, even washing your hands has been shown to be effective. It's commonly found in foods that have been overcooked or charred, especially meats like chicken, beef, pork, or even shrimp. And it's also found in smoked foods. And the reason for this is that the fatty content of the meat is then heated and the smoke rises and then re-enters into the meat. It's also really commonly found in cigarette smoke, so people who smoke are at a high risk for BAP exposure. It's a toxicant because it's found naturally and anthropogenically, naturally through the process of carbonization. So when plant and other organic matter die, it can go through the carbon process, and then anthropogenically, it's found in the charring of food or through the burning of fossil fuels. And as we know, the liver is essential for pretty much anything that enters the body, and BAP is no different. So one study in particular wanted to see the effects of the liver. They exposed flatfish to BAP and cadmium and the two combined, and it was found that BAP exposure caused a decrease in cell division. There was also an increase in Kupffer cells, so these immune regulators that engulf large particles or dead cells, there was an increase in those, and ultimately there was a higher amount of apoptotic cells in BAP and cadmium treatments. However, the two combined showed to have an antagonistic effect. Another study wanted to assess the risk of the liver and the kidney combined and see if there was a risk for liver and kidney disease. And they did this through the presence of free radicals. So they exposed BAP for 60 days at a dosage of 50 milligrams per kilogram of body weight, and then the other group had a longer exposure of 90 days. And ultimately it was found that longer exposure causes more increased risk for kidney and liver disease through oxidative stress. So there was a higher amount of lipid peroxidation levels, and there was a decrease of superoxide dismutase and catalase, which are both enzymes that protect the cell from oxidative stress. So all of this combined cause oxidative stress and ultimately cell death and mutation. Another study wanted to examine the effects of BAP on zebrafish embryos and whether or not exposure would later on lead to cardiovascular issues. And in fact, it did. The embryos were exposed to different dosages ranging from 0.05 to 50 nanomolar. And the group that was exposed to 50 nanomolar were more at risk for cardiac hypertrophy. However, all of the BAP exposed embryos had a higher heart weight to body weight ratio. So there was definitely, no matter the dosage, there was effects on the cardiovascular system. There was an increase in collagen. So as we know, collagen can cause tissue thickening and damage. Overall, it was found that early exposure to embryos, even at low dosages, can cause cardiac hypertrophy in zebrafish. And as we know, zebrafish are pretty similar to humans. Immunity was found to, in flounderfish, BAP showed an upregulation of cytokine expression and a downregulation of IgM and lysozyme gene expression, and ultimately an increase in oxidative stress, inflammation of immune organs, and it causes cell death. Pretty much in every organ there was oxidative stress and cell death. In the reproductive organs in particular, male and females were shown to have severe damage to the reproductive organs when exposed to BAP. In males, there was significant decrease of sperm motility. There was an increase in sperm mutation, increase in necrosis of sperm cells, and overall just sperm count density was down. In females, there was alteration to the hormones like progesterone, estrogen, and luteinizing hormone, and ultimately the follicle formation was altered. And even fetal development and survival rate were altered. So, for example, in the control group that was not exposed to BAP, they had an average of 8.6 rats per liter. And then as the dosage grew, even at low dosages, there was like 1 less rat per liter. However, when the exposure grew to 100 milligrams per meter cubed, they only had about 3 pups per liter. So that went down from 8.6 to 3. Ultimately, BAP shows to alter the reproductive organs significantly, and even high dosages of BAP were shown to cause sterility in some rats. Overall, there was damage to pretty much every organ, which can be seen in the pathology. So of the liver, there was expansion of the hepatic sinoids. In the lung, there was a thickened alveolar wall. So there was compressed alveoli and inflamed cells. There was inflammatory cell infiltration in the stomach tissue. So instead of a clear, smooth muscle layer, there was inflammation. There was really no difference in kidney tissue. However, there was like a little bit more staining in the nucleus of the hippocampus, but really there was no difference in the pathology. Overall, rats exposed to BAP showed a decrease in body weight and oxidative stress. The highest DNA damage was in the liver, and then the lung, followed by the kidney, brain, and last stomach. So it doesn't mean that there was no organ damage to the stomach or the brain. However, xenobiotics like BAP are processed by the liver, and that's probably why it's the most vulnerable organ. So we know the ADME process, absorption, distribution, metabolism, excretion. Benzopyrene, when it's ingested, it will go through the gastrointestinal tract, where it will then enter the blood and the lymph and either go to adipose tissue or the liver, where it will then be metabolized, turn into bile, back to gastrointestinal tract, and then be excreted through feces. It goes to the liver or adipose tissue because it's hydrophobic, and I'll talk about that a little bit later. It's possible to be excreted through urine, but it's not. It's mostly excreted through feces. And a terminal half-life of BAP in the blood was found to be 12.5 hours, 14.9 in the liver, 13.9 in the kidney, and in adipose tissue, 31.2 hours, and in the lung, 31.5. So it's really remains in adipose tissue and in the lungs. However, the study did recognize that the administrative process could have attributed to why it stayed in the lung longer, because it was injected instead of inhaled. And that's funny because in inhaled studies, it did not show to remain in the lung as long. But really in the liver and adipose tissues where it's pretty prominent. So BAP has a log KOW of 6.13, which means that it's hydrophobic and more likely to accumulate in the liver and adipose tissue, which is probably why it's most DNA damage, most oxidative stress in those organs. It has a risk-associated dosage of 1.4 times 10 to the negative 6 milligrams per kilogram per day, and the EPA has a standard of 0.002 milligrams per liter. In the workplace, there's a standard of 0.1 milligrams per meter cubed, and the permissible exposure limit for an 8-hour shift in like coal or tar volatiles, so people who work in those places have a limit of 0.2 milligrams per meter cubed. So people who work in those are really at risk for BAP exposure, and the EPA recognizes that. So as far as food goes, one study wanted to analyze like all the food in a Chinese supermarket and see what the BAP levels were, and it was found that chicken, fish, shrimp, and sausage, especially like smoked sausage, had really high levels of BAP. And in fact, 10% of the food that was analyzed had a higher BAP standard than the Chinese food limit, which is 5 micrograms per kilogram. The highest was 19.75 microgram per kilogram. So it's really prevalent in meats, especially smoked meats. In indoor air pollution, homes that had less windows, so one home that didn't have, it only had one window, had the highest amount of air pollution, like BAP, and the home with the lowest air pollution had, I think, 14 windows. It was a lot of windows. But ultimately, it shows how important air circulation is. And being in close proximity to an industrial site also increases your exposure to BAP. So wearing a mask when you go outside or things like that can really decrease your exposure. When BAP enters the body, it gets oxidized by cytochrome P450 enzymes CYP1A and CYP1B, and it turns into benzo a pyrene 7A epoxide, which is a polar substance more easily able to be eliminated. It's then metabolized by epoxide hydrolase, turns it into benzo a pyrene 7A dihydrogeol. CYP1A and CYP1B then react to it and form benzo a pyrene 7A dihydrogeol 910 epoxide, and that can then bind to DNA. So while the body can process toxicants, when it's introduced to too many toxicants, it can cause too many reactive oxidative species that can bind to DNA and damage it. So in phase 2, conjugation and detoxification enzymes protect micromolecules from binding to that benzo a pyrene 7A dihydrogeol 910 epoxide or other radical oxidative species. The EPA has a standard of 0.2 parts per billion maximum contaminant level. The goal is 0, but that's not really realistic. OSHA requires that people who are going to be exposed to this chemical are properly educated and receive proper equipment to reduce their exposure. And benzo a pyrene is classified as a group B probable carcinogen to humans, but due to there not being sufficient evidence or studies done on humans, it can't move up to that group A, which is a known carcinogen. And all these studies are really, overall, this was a really interesting study. I really enjoyed learning about BAP. I had no idea it existed, and even how I could be exposed to it potentially. I find myself avoiding, obviously smoking cigarettes and even plastic, because I'm like, those have chemicals, but even in the food that we don't know we're being exposed, even in the way we handle the food, the way we cook the food, the way that it interacts with our bodies, the enzymes that are present when we eat this food. It really opened my eyes and helped me understand the whole toxicology overall. And ultimately, I feel like pregnant women are the most vulnerable to BAP in particular, because the fetus in particular, it can cause cardiac issues later on in life. It causes development issues, even fetal survival. So I feel like I'm definitely going to educate the people around me on this chemical and other chemicals, because I'm definitely going to read up on everything that I expose myself to and just pass on the information. Thank you.